Hey everybody, this is Larry. This is day 17 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem. Add to number. Yay, with linked lists. This is a pretty standard E problem. Maybe not always with linked lists, but in general, it used to be one of those problems that comes up a few times on interviews and also in competitive programming. Those people... So a little bit of a history, maybe. If you're not interested in that, just fast forward. You have the technology. I believe it. You at home. But yeah, but there are a lot of competitive used to be more. Maybe this is, I don't know about more, but well, competitive programming predates the term competitive programming, but also like it predates the internet, right? Like there was a time when there was no internet doing some of this stuff. Or like the internet was barely working and stuff like this. So people just didn't bring templates and you go on site and you live and everything has to be in your head, right? And as part of that, and Java wasn't in the scene, on the competitive scene yet per se. I say that because Java has an excellent big integer library. But there used to be a lot of problems that deal with big ints, big integer and implementation of them, and so like some people would have a lot of this not only memorized. I mean, I wouldn't say it's memorized because everyone knows how to add and subtract and stuff like this. It's just about being careful and stuff like this. But like even the more complex stuff with respect to big ints and then implementing them in an efficient enough way so that they can also solve the other problem that is like a random combinatorial problem, and then you have a big int, and then you're like, well, now I have to figure out what to do. Yeah. So anyway, so this is but that being said, I think there's nothing conceptually or algorithmically difficult. You just have to be really careful with stuff like this, right? Everyone knows how to add in the sense that like you just do digit by digit, and linear time, linear space is really the lower bound, right? So you can't really do better than that in general. So okay, let's actually look at this list. Let's make sure that I didn't misread the problem like I did. Was it yesterday or the day before? So yeah, I forgot the K or something. All right. Okay, so this one's a little bit annoying. Yeah, I was gonna say the easy way is to kind of reverse it, because then you do the lowest significant digit first, and then you gotta do the carry bit. I don't know, because the follow up is a little bit tricky in theory, because I mean the answer is yes, but it depends on whether you have other constraints that you want with it, like maybe one pass or keeping it linear, because n is only 100. You don't even have to worry. Like you could do n square stuff and it'll be okay. Like you could do. So I don't know. That's a very weird problem, perhaps. I don't know if there's a easy way to. I mean, because it also like, on an interview, on an actual interview, this would be a two-person thing, right? Obviously, ideally, at least two-person, I guess, or two people. So what I mean by that is that so you could ask kind of questions of like, that may be pedantic but not pedantic or whatever. Like you can maybe solve it on a stack, meaning recursion, right? On the implicit stack, and that's, but it's not technically reversing the list, but it's like, but you're kind of doing it that way so that you solve the addition in the order that is kind of like reversing the list or something like that, right? So then it's like, so in that case, is that reversing the list? I don't know, right? And then of course you can also do the because I don't know, because it's if you're not reversing the list or like if you're not having a constraint about like one pass or two pass or something like this, then it's kind of also like almost meaningless, because even if you're not reversing the list, like you could just do the length of the list and then do math that way, right? I don't know. I'm just going to do the reversing the list and then I'm going to cheat afterwards, because I think that's more useful for teaching, but maybe not. But yeah, but actually I don't even know if it is, because reversing the list is just, I mean, making sure that you have, use a little bit dry. Driving means to don't repeat yourself. So yeah, so basically just having functions and stuff like this. So yeah, okay, so current is equal to node, and this might not be right, so yeah. Well, maybe current dot next, right? It's not node, none, then what are we doing? So next node is equal to current dot next, and this is stuff like this, maybe I'll change it. Stuff like this, I find it very often that just draw things out. If you have confused about, every line of the code make changes to one of the pointers or the values or whatever. So make sure, every line, draw out how you want it to look every step of the way, and then convert it to code, or do it the other way around, where you write the code and then make sure every step of the way it is what you think it is. I think that's basically the idea that I would try to impound on linked lists in general, and sometimes tree and graphs and stuff like this. Yeah, okay, so the next node is equal to next node. So we want the next node to point to the current node, but this would obviously get rid of the next node. So we want next node is equal to next node dot next, right? And then now current node is equal to, man, I think I'm getting this wrong, to be honest. Now we want to change the current node. Wait, okay. Maybe I should take my own advice and let me draw it out. It's been a while since I've done this, haven't I? Okay, so that was sentinel node. Okay, we want to move. Okay, so we have the current pointer and the current next. This doesn't come up in real life or competitive linked list in general. It only comes up like randomly on interviews. So this is like maybe my least practiced area in general, but maybe that's an excuse. I don't know. So okay. So okay, what are we doing again? Okay, so you have a node. You look at the next node, and then okay. So what you want to do is you want to do, right? Okay, and you want to. Or maybe I can just do something like, and then while this is not none, current node is equal to current node dot next. Current node dot next is equal to previous node. Next node is equal to current node dot next, and then current node is equal to next node, right? Something like this. Does that work? Man, I'm really bad today about. I don't know. Maybe it's the heat. I don't know if you can see it, but I'm sweating like a pig. My AC isn't strong. I need to get another one or something. But yeah. Okay. So yeah, let's take a look at it. And then at the end, return. Oh, this is definitely wrong because I don't do previous node is equal to current node or something like this, right? And then maybe return current node. I don't know if that's true. Well, the current node that next is none, so this is the last node. So yeah, okay, maybe. I'm really bad at this actually. Now I feel a little bit ashamed. Alright, so that's definitely not right. Oh, we don't change the current dot next. That's why, because current node dot next is equal to previous node. Because current node, okay, yeah. 3, 4, 2, 7. So actually, I was right. I just forgot this one line at the very end because it doesn't get processed here. And I actually kind of messed up here in a way. Or I thought I did, because I wanted to create a sentinel thing, but maybe I guess I don't need it the way that I kind of wrote the reverse node. So yeah, so then now we have, let's just say L1 is equal to right? We reversed both of them, and then now we can just do the lowest significant digit things first. Yeah, so let's just say current is equal to, what is it called, list node, right, of 0, and then while L1 is not none and L2 is not none, yeah, then what do? Then current dot value is equal to L1 dot value plus L2 dot value, right? If current dot value is greater than or equal to 10, then we have to do carry. I forgot carry. Carry current dot value. I mean, yeah, it doesn't. Yeah, I mean, I don't know. I don't want to say something about preconditions. Yeah, and then yeah. Current dot next is wait, how do I say it? Or how do I maybe I just need a dummy node. I think that's maybe what I want. Dot next is equal to this node of 0, and then right? And then now when that's done, current is equal to current dot next. Okay, I think that's how I want it. And then of course you have to make sure that oh well, you know, of course you have to move the other ones too. And then now you have to empty out these things. Ooh, I also, man, I'm like really sloppy today. Yeah, so then while this is not true, current dot next is equal to this node of 0. I guess the 0 doesn't do anything. It's equal to L1 dot value plus carry, and then you have this. You can also, if you're only doing addition, you can also do a carry with one pass at the end. I don't know how I feel about it. So yeah. And here has some code duplication. So I don't know. Maybe I could write this a little bit better. But I am just get it right first, and then we'll see, right? And then oh, I forgot to do the head. Wow, I'm like really all over the place today. Alright. I forgot to do the thing again. And so I just keep on allocating memory. Okay, so this is very wrong. Did I? How did I get 7088? Oh, I don't reset carry, that's why. Wow, really sloppy today. Apparently, I was saying so much about how like, oh, everyone should know how to do this. It is just addition. You know how to do addition. And then turns out I forgot to reverse this. That's why. But turns out I was wrong. I don't know how to do this. Oh no. Oh no, this is. Did I just forget to carry? Oh, this is silly. No, what? No, I put it in the wrong place. See, this is the problem with duplicating code, is that you put it in the wrong place once, You put in the wrong place 3 places, and that is why you try to dedupe as much as possible. I'm really sloppy today too. Usually I'm not that bad, but usually pretty bad, but not that bad. Let me try another thing. And also just create a new node. Okay, yeah. So, oh yeah. This is why we have testing. Oh man, wow! I'm like, this is embarrassingly bad. And you get to see it live. What am I doing? And this cannot be whatever, right? So I think that I don't even think I need that, but alright. But at least we tested it. This is ugly as hey. I think it is okay. And alright. I mean, I don't really have much to add to this one. This code is ugly. Don't use it. How did I do in the past? Oh. I just converted to a doubly linked list. Maybe that's smarter. I don't know. Apparently I did it 3 different ways, 3 different times. So I converted to a doubly linked list, and wow, this looks confusing as hey. I just got the length, like I said, and then also did it recursively. It seems like I did that recursively, so that we don't have to reverse it. And then today I just actually reversed it, so I just ignored it. What was the you said? Yeah, I think that's what I was saying, using stack. But like I feel like if you're using stack at that point, you're just using an array at that point, you know. So that's like a little bit confusing, or like it's not confusing. It's just I don't know, like very specific, you know. Like I cannot read your mind as to which way you want it that isn't this particular way, you know. And that's where you know, and that's where having an actual interviewer and you know you talk about approaches before coding would be helpful. But yeah, I am sweating. I'm gonna go back to the room with the AC. So that's all I have for today. Have a great week, everybody. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye bye.